Good morning, everyone, and welcome to JavaScript Combinators. Now, I want to be very clear. This is actually a talk about thinking about software that happens to be in JavaScript, much as all the other talks are about software that happen to be in English. JavaScript happens to be the language, like English, that most people understand, and also, like English, is very frustrating because of all of the mixed up things that don't really fit together. So it's I guess in that respect, it is the perfect language for a bunch of different people with different backgrounds communicating with each other. Now, this particular version of the talk covers what some people call ES6 or ECMAScript 2015 and a bunch of other things. But the ideas in there are actually applicable to most of the modern languages that people use. And I imagine most of the people here will be familiar with the particular syntax and so on. The talk is already online. I'm going to go through a lot of the code samples quite quickly because I'm assuming that most people would prefer to be able to go through them at their leisure on their computer rather than trying to go through things line by line. Now, in this talk, I'm going to be talking about combinators, which is an idea from computer science, and how they are expressed in JavaScript. And from the title and from the way I talk, you would think that the talk is about combinators. But this is actually not the thing. The talk is actually about composing and decomposing software. The combinators are just a tool that we use for this purpose. And while talking about composing and decomposing using combinators, you may think, aha, the talk is about composing and decomposing. But no, composing and decomposing software is just the tool. The actual thing we're trying to do is make the responsibilities of entities in our software and the relationships between them explicit. And that is really what this talk is about, making responsibilities and relationships explicit. So let's push the button and go. The first thing I'm going to start with is to discuss decomposition. By the way, I hope all of you like the De Stijl School of Art from the 1920s through 1940s, Mondrian, Jerry Rietveld, and so on. There will be more than a little of it here. So when we're decomposing software, the whole idea is we have like a big ball of mud, and when we decompose it, we pull it apart, not just because smaller functions are easier to understand and these other things people say. We pulled it apart in order to make responsibilities explicit. This is your job, this is your job, this is your job. It's not just about smaller, it's about focusing on the responsibilities. For example, we can take a look at this piece of software, which I think I copied from somewhere. And it actually does some sort of login thing and does some sort of a query for users and then saves something in order to create a current user. And it's not so long as to be impossible to understand. However, it's doing several things. Now, anytime we look at code in a talk like this, a common theme is, well, that's not so hard. Why do we need any sort of complicated thing? And the answer, of course, is that any code small enough to fit on a slide doesn't really need to be decomposed or turned into a monad or something. However, anything small enough to fit on a slide is small enough to understand in order to get the principle. So I hope you'll be with me on this and say that I'm just showing you these small examples for the principle of the idea, not that whatever I'm going to suggest is the one right way to refactor a particular piece of code. Now, this particular one here is doing, I believe, 4 things without looking over my shoulder at it. And a common way that we decompose software is to extract functions, break it up into little pieces. And in fact, many of you, I could ask you all to raise your hand if you feel like the exercise. Many of you have IDEs that will actually do this for you. You push a button, you select some code, push a button, and it'll pull it out into a function. And here we have a bunch of little functions that we've done. And pulled the whole thing apart. Now, once we've pulled it apart into little functions, the obvious next step is to compose the little functions that we pulled apart in order to make a whole again. Now, composition has this result of putting things together to make a whole, but the way in which we compose things serves as a signal to make the relationships between things explicit. So the decomposition is about the responsibilities. The composition is about the relationships. So here's our little code again. And there you can see one way, using promises and asynchronous functions, to make the relationship explicit. Notice these words, then. That is a form of composition, but it is also a form of telling the person who's reading the code what is the relationship between these parts. This thing happens, and then this thing happens. Now, as I said before, decomposition is about making responsibilities explicit. Every time you have a responsibility, you have someone who's responsible for it. You have some sort of an entity. I anthropomorphize things. We say somebody responsible for something as if they're actual. We sometimes use words like actors in architecture. But fundamentally, there's some sort of an entity that exists to have a particular responsibility. And when we decompose, we are identifying the important entities, the important actors, the key things that need to be in it. And when I say things, I don't necessarily mean models of concrete things in the real world, but the actual ideas that represent the entities. And when we compose those entities together, we do them with relationships. So let's go back to our decomposition and play with this idea a bit more. Now, we just did the extracting named functions. And this is a very obvious way to decompose. It's probably the first thing everybody learns when they're sort of learning not just to write software so that it works in the first place, but how to refactor it and redo it or play with it. But it's not the only way. When we extract functions, what are we doing? We're reaching in and saying, that's an entity, let's pull it out. That's an entity, let's pull it out. This one, this one, this one. We're going from the inside out. And quite obviously, when I set it up this way, you're all smart people, you know what's coming next. If there's a way to extract entities from the inside out, there must be a way to go the other way. Now, when we extract entities from the inside out, the inside is the implementation, the outside is the interface, yes? So we are decomposing things by decomposing the implementation. In our function before, we didn't touch the way the whole login worked. We just touched the way the relationships were connected, the entities were connected to each other by turning them into promises with thens as opposed to callbacks. So we're going to go the other way. Now here is a function that you will find in a number of popular libraries. You can write it yourself in 1 or 2 lines of code. It's in Lodash, it's in Ramda, it's in underscore. And what it does is it reaches in and grabs a list of property values. So if you have a bunch of users, it can grab their names, something like this. And here is an example. Oh, look, some artists from the Stale movement again. And our pluck, there I make a 1-line definition at the top. I have an array, each of which has some objects with some properties. And by plucking the names from the style group, we get the names of each one of these fantastic artists. If when you walk away from this, you say, I don't know, his software ideas were not so good, at least go and learn more about these artists. That is a lifelong value for you. Now, if you look at the interface for the pluck function, as you can see, it has 2 pieces. What property are we extracting, and what collection are we extracting that property from? That's its interface. Now, we can actually decompose that interface. We can make a function called pluckFrom. PluckFrom takes a collection and then applies pluck to the collection, so it's only using half. Pluck's interface takes 2 pieces. PluckFrom's interface only takes 1 piece. We're decomposing the interface that had 2 pieces into part of the interface that only has 1 piece. This is fundamentally the same thing as decomposing the inside of a function that had 2 parts of its implementation into 2 pieces. Same idea, only we're working with the interface. PluckWith is just like pluckFrom, only pluckWith takes the property as its piece. So pluckFrom and pluckWith are two halves of the same pluck function, but they've been decomposed via the interface rather than via the implementation itself, which is a good thing, because for this incredibly ridiculously simple example, pluck is so small, it's only one liner, that's not really useful to decompose its implementation. Now, once you start getting people who really get addicted to functional programming, it's like crack for the brain. They talk about this idea, they say it's partially applying a particular function. This is true. And partial application, when people start talking about it, and there are in fact partial application functions available for you in popular libraries, or you can write them yourself in one line of code, this is a way of decomposing interfaces. It's not the only way, but it's the way I'm going to share with you today, because frankly, when you're sitting and looking at somebody's slides and so on, a more complicated way of doing things with more lines of code is not really a useful way to communicate the idea. But if you take the basic idea and go forth into the world, you will see the pattern in many more ways. Now, before, we decomposed from the inside out. Now, we decompose from the outside in. Partial application is just decomposition of interface. It's just maybe, I don't think I'm the only one. I'm a bit of a taxonomist. When people show me a bunch of different ideas, I try to say, what are the underlying things all these have in common? It helps me understand them. That doesn't mean that, when I'm writing code, I actually use words like, oh, I see, we're going to decompose the interface. You won't find me using these words in a lot of pull requests at work. But at least to understand the principle helps me to internalize how various things work. It's nice to have names for things and names for ideas. It helps us put them in little buckets, or some of us, in order to think about them. Now I'm going to shift gears a little bit. We've talked about decomposing the implementation and decomposing the interface. I talked about how the purpose of decomposing something is to make responsibilities explicit. Yes. And I talked about how recomposing them is to make the relationships explicit. So let's look at some more examples. What are decorators? A decorator is some kind of higher order function. It takes a function and it modifies or adds some functionality to the function you already have. And in principle, the original function should be recognizable and have a similar responsibility. So it modifies a responsibility. Partial application is a kind of decoration. Let's take a function and let's modify its responsibility. Now, here, if we take the way we took pluck and turned it into pluck from, we can sort of generalize that. What if there was something else that did this work for us? We'd end up with this function called leftApply, which can take any function like pluck and turn it into a pluck from. If we have this leftApply, we can make pluck from just by applying it to pluck. Now, it's first thing in the morning. We're not going to go through this all line by line in excruciating detail. However, the idea that we can take from it is that every step we take that kind of abstracts a little bit this idea of pulling something out of the interface and decomposing its interface takes us to a more generalized example. We're not going to pile all the way up to some sort of complicated monad. However, a funny thing happens if you do a lot of left application of left application. Does everyone know what this stuff is? Curry powder. LeftApply of leftApply and leftApply is in fact currying. And why this matters, and again, this code is something that you can look at more at your leisure. I personally don't like to hear about code from speakers, so that's why I don't spend a lot of time going into all the details. I prefer to look at it on my laptop later. But why this matters is that when people come up with an idea, what is left application, what is partial application, what is currying, and there's all the little details between them, and we understand what those details are, But if we understand that fundamentally they're about decomposing interface and they're just different, more indirect or more abstract versions of them, we get the basic principle. Now, if we look at this partial application, we can come up with other combinators that decompose interfaces. We saw how to use left application to take pluck into pluck from. This is called the C combinator. It takes some function, V and C, and it says, let me turn it into a function where I get a value, and I will sort of apply that value later. And so the C combinator allows us to take a function and turn it into a function that already has some future value to be applied later. In our particular case, we end up with a pluck with rather than a pluck from. However, if you're working later with promises or observables, the same principle will apply to working with things that come later in time. Another example, we can write a function. If we take a function get that extracts a particular value from an object, we can get the name from an object that has a name. We can use the C combinator to create get with. We can say, hey, if I want names of things, I can use get with to create a name of things function. We're doing the same thing again. We're taking a function like get, and we're turning it into a single responsibility, a single thing. I want to get the name of something. It's the same thing as decomposing by extracting functions. We're just extracting pieces of the interface. It looks more complicated when you're first starting in programming because we spend so much time thinking about the way code is composed in the implementation and so little time thinking about the ways code is composed in the interface. And languages like JavaScript and so on, which are rooted in 40-year-old history, spend so much time giving us things, loops and fors and for-ofs and for-ins and things that compose things together in the interface, and they give us so little that decomposes or composes, so many things that compose things in the implementation, and so few things that compose things in the interface that it seems very strange. And if I'm going quickly and you're not familiar with the combinators, you say, oh, this seems like gobbledygook. But it's only a historical accident that our languages and our culture have spent so much time figuring out how to glue statements together within a function, and so little time figuring out how to glue the interfaces of functions together. But fundamentally, this is no more complicated than what we do with statements. However, it is more unfamiliar. So if I say it's no more complicated, and you're looking at it and saying, well, if it's not complicated, Reg, you're doing a very poor job of explaining that it's not complicated because it doesn't look that simple. Again, the problem is that both of us, you and I, did not get lots and lots, decades of experience in blog posts and whatever else, explaining how to decompose interfaces and put them back together the same way people spent decades talking about how to decompose function implementations and put them back together in a different order. Ah, there's a nice cafe. I would really love to go for a beer there one day. Now, with our get function, it took two arguments. We knew how to turn get with and break it apart into a function that takes one of the two arguments. And then we knew how to decompose that by saying, well, this one argument could be very many things, but what if it was just one particular value? Both fundamentally the same idea. One more. This one's very common. Map takes a collection and a function. Everyone has seen this. It's a standard method in JavaScript. Map with simply says, hey, if I already know what the function is, then I can call map with on the function and apply it to a collection. Names of takes our original name of and says, hey, what if I were to do a map and apply name of to it? One of the things that's interesting about that example, well, maybe I should put it back on the board, is that you can see that these individual pieces can be reused in different ways. Just as we could reuse individual functions that we extract from an implementation, we can reuse different ways that we extract pieces of an interface. Fundamentally, all we're doing are decomposing things from the outside in. No different than we decompose things from the inside out. Speaking of composition, if at some point in the future you're having a beer or a coffee and somebody is saying, Ramda, left application, functional programming in JavaScript, what good is all this? Why do I need to know about querying? What's the point? Or you're even looking at a blog post and saying, I have 15 minutes, why do I want to invest it in reading about this blog post? If for nothing else that you take from this, besides the importance of learning about the stale movement in art and architecture, the other thing you can learn is, I can learn more about decomposing interfaces so that my understanding of how to work with the interfaces of functions and the way they go together is as strong as my understanding of how to work with the implementation of functions and the way they go together. I will bring these two things into balance. Interesting tunnel. I don't know why I selected that. I'm not sure what it has to do with the other pieces of art. Let's talk about simple composition. This is the compose function. It takes two functions and makes a new function that takes a value, passes it to the first one, and then takes the result and passes it to the second. It's a very common thing we do all the time. In expressions, if I say, what is 2 times some number plus 1, we're composing plus 1 with times 2. Did I miss one? There we go. So here are some stale artists again. And we have pluck with, which happens to be the composition of map with and get with. We saw previously another way to make pluck with. This is a second way to make pluck with. Now earlier, I said the decomposition is about identifying entities. Knowing 2 different ways to compose the entities back together means we have 2 different ways to identify the relationships between the entities. And in much more complicated pieces of software, when we were considering refactoring, that's the whole point, isn't it? We already have a piece of software that works. We could leave it alone. We could refactor it one way. We could refactor it another way. When we're in a pull request having a discussion, what are we really arguing about? What are the most important entities, and what are the relationships that we want to identify? It's the same thing even on a smaller scale. The fact that pluck with can be put together with compose, as opposed to extracted with left application, just gives us another tool for figuring out how to identify the relationships between things. Again, is it really important that you walk away with an exact understanding of compose or of left application? All of those things can be grasped easily from blog posts, books, workshops, and so on. But the fundamental idea is the more tools you have for being able to take functions or bigger pieces of code apart, and the more tools you have for putting them back together, means the more ways you have of identifying responsibilities and relationships. So when somebody says, all right, functional composition, I know that in JavaScript they're talking about adding a pipe operator. I know that there's a then between promises, and so on, and that's a kind of composition. Like, why do I care? You will say, you care because you want to make a relationship very explicit as opposed to burying it in code. And there's more ways to compose things, fortunately. Here we have some baking software that involves mixing, baking, and cooling. We've already extracted some pieces, as you can see, as we would if we were using extracting functions. Now here's an interesting idea. Before is a kind of composition. It says, I have a function, and I have some decoration, which is some other thing that I want to do before I execute my function. It returns a new function that's going to first apply the decoration and then return the results of the function. So baking bread is, I'm going to bake, but before I bake it, I want to mix it. What does before teach us? It's a kind of composition. It's fundamentally the same as the compose function that we had before. But what does it do? It names the important relationship between mixing and baking. We can do a similar thing with after. And it also, again, names a relationship between two things. So once you have something like the original basic functional compose in your toolbox, you can make variations that for each one describes a particular relationship between the functions. They may mathematically be doing the same thing as compose, but naming a particular relationship helps make the code more obvious. Now, before itself can be decomposed, as you can see, as can after. And by breaking them apart, you turn them into combinators. You turn them into functions that can modify another function. Before with says, I'm going to take some function that is a decorator, that has some decoration, like before showing this index page, check that the user is authorized. And I'm going to create a decorator, a function that takes some other function and checks authorization. Same with after. Maybe after with takes some logging and turns it into a decorator that can take some other function and log the result after it applies the function. Do you need to do this? That depends upon whether you wish to make a relationship explicit and to identify a very specific responsibility. Now, that's not the whole story. We can go further. One of the annoying things about JavaScript is it has what I call colored invocations. The way you work with pure functions is not the way you work with methods, because with pure functions, you just sling values around, but with methods, you always have to pay attention to this. And you have to use functional application, otherwise you lose the context. So when you wish to decorate methods, as opposed to just pure functions, you need to write your decorators and your composition such that it respects the current context. Now, fundamentally, we're about to do the same thing as we did before, only now we're going to pay attention to the current context, or our this. I think JavaScript programmers, myself included, seem to spend most of our time thinking about this. Now, you can decorate functions, and once you get sort of the idea, you say to yourself, well, I'm not a closure programmer, I'm not a Lisp programmer. JavaScript is a multi-paradigm language, so anything in JavaScript ought to be decoratable, and indeed they can. Decorate method with, I think this is the worst named function I've ever written, takes some series of method names, and it takes some decoration you wish to do, and it defines some properties on an object such that those properties, if they happen to be function, are decorated with this particular method name. That sounds like a mouthful. How many people here use Rails or are familiar with it? All right, we have some people confessing. That's very good. This is fundamentally what filters are in a Rails controller, aren't they? I have some functionality like logging or authorization or something, and I'm just going to name all the methods that need to have this particular thing run before it. Of course, if you look at active support or whatever it is where you find that in Rails, you'll find an awful lot of code. JavaScript actually can do this in a very, very simple way. So if I write before all, using my decorate method with, Or after all, these are the same as Rails filters. And if you look here, I've written before all, I want to invoke the mix function before I make. And after I do my make, I want to invoke cool. And then I'm going to pass it a class. This can be written in some better ways, but this particular way I've written it here helps to name the relationships between mixing and making and cooling and making. And if you look at the way I particularly moved them, because they're outside of the class, it allows us to separate the responsibilities rather than pushing that stuff into the class. So when you look at the class, you just see a method like how to make something, and you don't have to worry about a bunch of other things that might be cross-cutting concerns. Now, actually, mixing and cooling are probably not cross-cutting concerns, so maybe my example of baking is not a good one. But things like authentication and logging normally are considered cross-cutting concerns, and you normally don't want to encumber a particular method with all of those things because you want to separate those responsibilities and then make the relationships explicit. So maybe I'm not so great at picking relationships, picking examples, and I'm definitely not very much of a baker, but the principle is very important. Now, in the future, there will be easier ways to write this in syntax. I don't know when they're going to get together with this. There will be some class decoration sugar, so instead of nesting things inside of function calls, you'll be able to use an at. And I think that will be very nice. I don't know when that will land. It was in Babel for a while, and I think now you have to use some particular flags in order to turn that back on. But when that's possible, it will make the writing of classes much, much more easy to read. And again, what do? We decompose things to separate responsibilities, and then we name the relationships between them in order to identify what the relationships are. Well, also, in the future, instead of having all these weird things, we'll have some nice syntax for modifying individual methods. Like, this syntax already exists in a bunch of languages already. JavaScript will no doubt have it by 2020. If you're already using a language that has this, fantastic. Fundamentally, I keep saying the same things, because my talk is really only about two subjects. Although there are a bunch of different examples, some more readable than others if you're looking at them for the first time, they're all the same thing. So I'll say it for the 10th time. We decompose things in order to make the particular important entities explicit, and then we compose them back together in order to make the relationships explicit. We did that with extracting functions. We did that with promises. We did that with partial interfaces. We extract closed-over bindings. That's a complicated name for what we did with things like getWith. We saw composition. We saw with decorators. We saw functional decorators. It's the second one there. Class decorators, method decorators. But they're all the same ideas. Their particular individual names are not as important as the idea. And the idea, make the responsibilities explicit, and compose to make the relationships explicit. This is a very famous quote by Dr. Phil Carlson, who's unfortunately no longer with us. There are only two hard problems in computer science: cache and validation, naming things. Actually, there is a third problem, and the third problem is people making jokes that take this quote and add off by one errors. Now, naming entities is hard. This is fundamentally what we do. I mean, it's not just getting the software to work, but when you're trying to communicate with people an idea, you have to try to figure out what the important things you're trying to say are. It's just as hard in software as it is when making a talk, or making a Hollywood movie, or telling someone why you love them and why you want them to spend the rest of their life with you. There's all these ideas, and you have to try to, what are the core ones I want to communicate? No programming feature is going to make that easier. This is the hard work we have to do. Hopefully, good languages and tools declutter a lot of the sort of accidental complexity, but that's the fundamental work of thinking and communicating. You have to figure out which entities need to be named. The same thing is true of relationships. Naming the relationships between things is hard. If we just decompose everything until there's nothing but one-line functions everywhere, we just kind of copped out. We've named everything, which means that when someone's reading the code, including yourself 6 weeks later, you have no idea which ones are important and which ones aren't. It's as if I told you, I've written a play and there's 180 characters in it. You have no idea who's the star, who's the co-star, what is the main theme. It's not obvious when there's 180 people in some ensemble cast. You have to decide for yourself who are the main characters and who is pedestrian number 3 in a particular scene. And no piece of code makes that easy. However, things like combinators give us a language for naming things. They give us a way to talk about the relationships between things. They give us a way to talk about the pieces of things. And when we have that language, now I'm not going to tell you you absolutely need to know about the difference between partial application and currying off the top of your head, or the difference between a decorator and normal method composition. However, once you've begun to internalize the concept, however it is expressed in the language that you use, or the library that you use, once you've internalized the concept, it helps you to think better about the hard problem of figuring out which are the important things to name and which are the important relationships to name. And however you might express them, the fact that you give it that thought is what really matters. Now, I've rushed through the exact technique of functional composition and so on. There's lots of materials on this. I've even heard that some fellow has written a book about JavaScript and combinators and things like that, which is free to read on the net. Don't spend any money, you don't have to. But you know what? It's not really that important. And I'll tell you why. It's really important in a way for us to stand on the shoulders of people who've come before us and to build on it. But it's not important for us to cling to the past and try to do everything the way people did when they wrote Lisp in the 1960s, or wrote Smalltalk in the 1980s, or wrote Ruby in the 2000s, or any of these other things. All fantastic work. But there's a saying, and the saying is, do not follow in the footsteps of the sages. Don't copy me. Don't do what I do. Don't do what other people have done. Learn from it. But the important thing is not to follow in their footsteps, but to seek what they sought. And that's what I will leave you with. Please go out there and seek what people have sought. Take these ideas and then find your own new directions to take software. Thank you very much. We have 5 minutes for questions. All right, hang on. Excuse me, Reg, you said that I could read these online. Is that true? Yes, I'm on GitHub under Ragenwald, and you'll find that this presentation is online, including all of the code samples. I have a GitHub repo called Presentations, and this particular one is called JavaScript Combinators, and it's the exact slides and so on you can get from SpeakerDeck, as they see here. However, the source code for this is actually in Markdown. I use a program called DeckSet that presents it from Markdown. So you can just, right from the web right now, on your phone or on your laptop, copy, paste samples, put them into ES6 Fiddle or Babel and so on, and work from there. Does that answer your question? It does? Good. Next question. Okay. Could I ask another question? Okay. So some people tell me that this stuff is not as practical as learning frameworks and so on. That's a very good point. The truth of the matter is, if you don't pay your rent, it is very difficult to have spare time to read about combinators or go to conventions and so on. So what I would say is this. Early in your career, you want to build a solid foundation. And theory and these ideas are part of that, because the earlier you learn something, learning that comes later, like when you're picking up a new framework, you learn in the context of the things you already know. So earlier in your career, you should build as many fundamentals as possible. I'm not saying that you must get a degree in computer science. I can't tell you what path to take, but you should be extremely curious about ideas. Now, later in your career, you want to blend learning new things with applying the ones you already have. You don't want to be a lifetime learner. As exciting as that is for you, you're not going to help us get to Mars, to quote from the previous speaker. So you have to, ratchet down the learning of theory and ratchet up the application. However, if, like me, you're in your 50s, you might say to yourself, well, I'm not 15 or 22 or 35 anymore, so should I still be learning? And to use another very old quote, the best time to plant a tree is 30 years ago. The second best time is now. So I do believe you should continue to explore new ideas and to explore some fundamental ideas. And I do believe they will pay off in terms of you're picking up a framework like Ember or React, and you say, this seems familiar. There's that thing of Ragenwald's. I didn't actually go and read all the source code samples like you suggested, but I know where to find it. Let me go take another look. So it will still help you, even if you're not at the beginning of your career. But you do have to, apply some moderation. You should also be learning about frameworks and about how to use your IDE properly. And you should be learning about tools like GitHub, and maybe you should be learning about how to give good feedback, as you may have heard in last night's closing keynote and so on. You do have to, later on, as your career progresses, learn a variety of things, not just fundamental ideas. But you still do learn some. Does that answer your question? Excellent questions from this audience. You guys are great. But can we get a question from somebody else? Yes, I see a hand up there. Excellent, yes. So if you get a little bit over-enthusiastic about theory, you sometimes write code that is correct. It is correct. It does what it's supposed to do, and it is nicely factored and so on. However, it's easy to read because you have the context. You were here in this room, and the next person was not. You went from here or something else that inspired you to read a different book or so on. The next person did not. So there's a couple things. The first is, people like me have a responsibility to continue to evangelize this so that the next person, in fact, says, oh yeah, I know what compose is, and in fact, they can lecture you about parts that you didn't know because they're younger and they picked this thing up earlier. Sometimes they don't. And the truth is, you have to use some moderation. Sometimes you just have to use some of these ideas, but express them in a way that is more accessible. Generally, if you find, as I said, when talking about, it seems very complicated when you talk about method decorators and before and after, but these are the exact things that you will find in the Ember framework. You have oh, my brain is cramping now, but you have ways of writing computer properties, and they give you a whole library of different computer properties and so on. That's this stuff. It's just the way Ember expresses it. So it may be correct to look at the audience, the actual people you work with, your actual team, and say, okay, I know what this is, and I could write it as a one-liner, but I will use the Ember thing because that is going to be more accessible to my team. That is your job, to make these decisions, to make these judgments. There is no, this is the correct way. So it's a very good question, what do I do about this? And the answer is you have to use your judgment. You have to use a small part of educating people yourself. You have to use a small part of using the right amount of a more theoretical concept, but not too much so that it becomes like some sort of religious text. And sometimes you have to say, this is a great idea, but I'm not going to write it this way in this particular function. You may have to pick your spots for where you use some of these techniques. And it may be, for some people in this room, that the absolute right thing to do is to learn everything about them so that you understand what existing frameworks and so on are all doing, which helps you use them more effectively, without ever once writing a compose function or using things from Lambda or Lodash like pluck with or map with and so on. It's quite possible. I think if you understand these things, you're a better programmer, whether or not you actually write a line of code in this exact manner. Does that answer the question? Well then, I say go forth and talk amongst yourselves and have a great second day of the conference. The first day was awesome. The second day, it looks like it's going to get even better. Thank you very much.